Welcome to the podcast for healing neurology, where we talk about everything that can help heal your neurology, which is really everything from food, lifestyle, and medicine to nature, culture, and politics. There's no topic too big or too small. I'm Jillian Ehrlich, family nurse practitioner certified in Ayurveda and functional medicine. And we have a really interesting guest today, although he describes himself as not a physician and giving you the level of advice that you might get from a nice neighbor who changes tires. Mr. Alan Cash is an incredible scientist who's pioneered a product called Oxaloacetate, which or Benagene is the commercial product, and we're going to talk about that today. Mr. Cash serves as founder and chief science officer at Terra Biological, researching into the molecular and genomic mechanisms of aging and the effects of caloric restriction on aging. Mr. Cash developed unique molecular methods and compounds to mimic calorie restriction and extend lifespan in laboratory animals. Mr. Cash has an MS in physics from the University of Oklahoma. As an entrepreneur, Mr. Cash has gained recognition and awards from the White House, Inc. 500, Ernst & Young Entrepreneur of the Year, Deloitte and Touche Technology Fast 50, and Top 100 from Hot Firm. So, Mr. Cash, welcome. We're so happy to have you.
Well, I am so impressed that you were able to read that without stumbling over that. I can't even do that. That's really impressive. Wow.
Yeah, I got some skills. So, all right, when we talk about oxaloacetate, which the commercial product is either Benagene or Jubilance, we'll talk about what those are. Oxaloacetate is a metabolite in the mitochondrial Krebs cycle. So if it's okay with you, let's start out with big picture. Let's talk about mitochondria. Like, what are they? What are they doing? Why do we have them? Where do we have them? And a lot of our readers will, this might be review for a lot of our readers, but let's just start so we have a kind of a point of entrance here.
Yeah, no, that sounds like a great place to start. I'm not a physician and I'm not a biologist. So I got into this because I was looking at energy. As a physicist, we look at things like that. One of the things we wanted to look at is why some of these energy pathways fail us. And the mitochondria, they're these little organelles that are inside the cell, and there are bunches of them. It's not like there are 5. There's like 1,000 or 4,000. And the classic shape is the kidney shape, but they're all sorts of shape. And depending upon how the cell is doing, they'll actually change shapes and they'll split and they'll recombine. But what they do is they process energy. When we take sugar into our cells, it goes into the main part of the cell, and that's called the cytoplasm or the cytosol. And there it breaks down into pyruvate, which is another metabolite. And then the pyruvate goes into the mitochondria, and it's essentially burned with oxygen. So we're using a chemical burning to produce ATP, which is the energy currency of the cell. So if you don't have working mitochondria, it's very difficult for you to have working energy. In healthy cells, I think the mitochondria produce about 94% of might be 92, 96, somewhere in there, of the percent of the energy that you use, which is pretty astounding. The other energy comes from in the cytoplasm. The pyruvate can break down anaerobically without oxygen and through a fermentation process. And that's a way to get very quick energy. And sometimes your cell turns that process on so that you can respond to injury or disease when your body needs a lot of energy. But the mitochondria are pretty much this amazing little tiny organelles that have something inside them called the Krebs cycle. And oxaloacetate is one of the components of the Krebs cycle. It's the component that's in the smallest amount, as a matter of fact. And in spinning this Krebs cycle around and around, that's what generates energy.
So mitochondria then produce our energy. And it's that combination of that Krebs cycle and then that electron transport chain, right? And then we get our key. So where do we find mitochondria in our cells? Where are they in higher concentrations? Where are they in lower concentrations?
Well, the highest concentrations are in cells that require tremendous amounts of energy. So, for instance, the heart muscle has tremendous amount of mitochondria. In birds, breast tissue will have super high amounts of mitochondria because they actually fly. So the brain also has a lot of mitochondria. These are high energy. So, for instance, like the brain, even though it only weighs about, I can't remember what it weighs, but there was some figure given to me where the brain is eating up more energy than any other part of the body by weight, because it's just a huge energy sink.
Yeah, there's a lot going on. Hopefully, when things are going well, there's a lot going on.
In some of us, right?
Right. I feel like there's a political joke in there somewhere, but that is.
No, I am decidedly unpolitical. I'm so tired of the politics. I just want to help people.
Yeah, I agree. So when we think about mitochondria and mitochondrial dysfunction, what is happening, or what are some of the things that happen in mitochondrial dysfunction?
Well, there are a lot of ways that mitochondria can go bad. They have very few genes. They have their own genes. So the nucleus has its set of genes, which is the bulk of what we're dealing with. And then there's the mitochondria, which has I think it's 13 genes. It's very, very little. Mm-hmm. And if one of those is malfunctioning, of course, the whole system just goes haywire. Other things that can happen with the mitochondria is that they become incredibly stressed, and they start, instead of, one of the neat things that they do is that as they're producing energy, they are also quenching free radicals that are produced in the energy, in the burning of glucose. And that's what makes mitochondrial energy very safe. Whereas if that occurs in the cytoplasm through fermentation, you get all these free radicals that just, float around in the cell and start taking out molecules. And it can cause quite a bit of damage over time. So as far as diseases that affect mitochondria, I would say pretty much all of them. We see that more and more and more, that chronic disease is definitely tied to mitochondrial malfunction. But so is your everyday, disease and injury. The mitochondria are just about everything we see with mitochondrial damage is a problem. The good news is that our cells will remake mitochondria. And so there's a gene called PGC1 alpha, which, if you can increase the expression of that, it actually turns on the process to make a lot more mitochondria. So when you think about it, there are two things here that have to happen. One, you got to have fuel for the car, okay? And that's your glucose coming in. And then you've got to have an engine that actually runs, and that's your mitochondria. And the great thing is that there's so many mitochondria in the cells that if some of them are defective, it can be overcome with all the other ones that are still working. But the key is to keep your mitochondria healthy, and that means you have to turn them over every once in a while. So turning on that PGC1 alpha gene helps to do that.
Do you have any tips or tricks for getting that gene to roll?
Well, of course, oxaloacetate. Why else would I bring it up? No, seriously, we did some preclinical work, and one of the things we found that oxaloacetate supplementation does a lot of interesting things from a metabolic standpoint, and that's probably because it's in such short supply in the Krebs cycle and throughout the cell that it can act as a signaling molecule once you increase the amount of it. There was a great paper in Nature Metabolism about 2-3 months ago where they were looking at oxaloacetate as the controlling factor as to whether the cell would try to process glucose in the cytoplasm through fermentation, or whether it would actually transfer it to the mitochondria and burn it through oxidative phosphorylation. So oxaloacetate is pretty key for these processes. And we know that intrinsically because there are some children that are born with the inability to produce oxaloacetate. And typically, I said children purposely because typically they don't make it into adulthood.
So when we talk about mitochondrial dysfunction, we can kind of think of it perhaps in two sorts of legs, one leg or one kind of arena being that the genetic mitochondrial diseases. And we've talked on this show before, certainly about how mitochondrial disease departments are often at children's hospitals, because when there are severe genetic deficiencies in mitochondrial production or function, that it really does present very early in childhood.
Yes, it does.
But that now what we're seeing is our load is so great, our burden, our toxic burden, our mental stress burden, our supports are so lean, like first, healthy circadian rhythm and a healthy microbiome, that now we are seeing these mitochondrial dysfunction, diseases of mitochondrial dysfunction that we can call acquired as we develop them later in life. Does that sound right?
It does. It certainly, we've worked with UCSD's mitochondrial center with children, and we're always happy to help there. But we also do see mitochondrial dysfunction later in life. I mean, several diseases have established firm links to mitochondrial dysfunction. And I mean, you can go through the literature and just see disease after disease after disease, and it's mitochondrial function. Now that's not the whole story, of course, but certainly it's a component of the story. And so if we can keep our mitochondria healthy and happy and keep that engine running, that's a good thing. That's a good way to keep healthy people healthy.
Awesome. And we've definitely also talked on the show before. And if you're a patient in our clinic, you've heard us likely talk about the cell danger response, which is a theory pioneered by Dr. Robert Navio, who's at UCSD, University of California, San Diego, that you just mentioned in their mitochondrial department.
Yeah. Bob and I've had a lot of chats about that. Huh? One of the things that we've seen with oxaloacetate, and this was at the University of Kansas by Russell Swerdlow and his team, is we see a decrease in the activation of NF-kappa B, which is a major player in inflammation response. So kappa B is this protein that once you're stressed, whether it's chemical stress or environmental stress, or you're really hungry, there's a variety of things that turn it on. And it moves to the nucleus, and then it turns on genes that have to do with the cell danger response, and basically saying, hey, let's fix this body. So it turns on all these cytokines, and you may have heard recently in the news, how potential viruses like COVID can cause a cytokine storm when it turns on these pathways too much. Certainly, it's needed because you need to be able to regenerate your body and need to be able to take care of these things. But sometimes when it's activated, especially by viruses for some reason, like Epstein-Barr and some of these other viruses, the cell danger response doesn't turn off. And you just keep in this inflamed mode, and it really wears down on you. A lot of chronic fatigue patients have this situation where their NF-kappa B levels are just highly elevated, and they're chronically inflamed.
So if we're going to talk about mitochondrial dysfunction and some of the treatments, if we're not starting yet into oxaloacetate, just to briefly mention, what are our other options for addressing mitochondrial dysfunction? How do we strengthen our mitochondria?
What doctors have told you for years and years, a good diet and exercise are the two best ways. And that's probably, true of 99% of what's out there. I mean, if you can, exercise regularly, take care of yourself, floss your teeth, important stuff. That goes a long way towards keeping your mitochondria healthy and happy. Keep the inflammation pathways down. Diet has a lot to do with that. There are certain foods that are pro-inflammatory. We know what they are. There are other foods anti-inflammatory. And so that's something that you can control pretty much. You can make those choices. And I'm sure you talk about that with your patients quite a bit.
And work on myself. It's not always easy making the right choices. So.
Ice cream is just so good.
So good.
Yeah, but, so is broccoli. You just have to have a different mindset.
Right. Well, and sometimes I think it's like, what is your body? You have to get below stress cravings to listen to those true cellular cravings.
Yeah.
So now let's dive a little bit into specifically talking about oxaloacetate. Can you talk to us about the history of oxaloacetate, what it is, where is it in the Krebs cycle? How did we discover it? When did it start being developed? All that stuff. Talk to us about oxaloacetate.
Yeah, sure. A lot of the work on oxaloacetate was originally done by Hans Krebs, who the Krebs cycle is after. Another name for that is the citric acid cycle. And what he found is that it's the power plant, part of the power plant that's in the mitochondria that helps fuel our bodies with energy. It turns out that there are a lot more pathways that oxaloacetate is involved in. One pathway is it allows, when you're fasting, to take fatty acids and turn them into sugar so that you can feed your heart and your brain so that you don't die. And so that's a pretty important one. It also helps with detoxification of ammonia, specifically in the liver. And so there are some really important functions of oxaloacetate, which is why, again, if children are born without the ability to produce that, it's a real problem for them. They typically don't make it past the age of 1.
When was it discovered, or when did we start really researching this?
It was discovered pretty much when Krebs was doing his work, was in the 1950s. I think oxaloacetate may have been discovered before that, maybe as early as the 30s, but I'm not quite sure. But Krebs certainly brought it to light because of the importance of the citric acid cycle. And what oxaloacetate in that cycle does is it turns into citrate, which is kind of like vitamin C, and it came from malate, which is another energy metabolite. Apples have a lot of malate in them. The interesting thing about the Krebs cycle is that usually oxaloacetate will break down into malate because it energetically, that's the preferred thing to happen. So in the citric acid cycle or the Krebs cycle, it actually goes uphill to make from malate to oxaloacetate. It actually the energy usage goes uphill. And the fact that it's able to do that because of the enzymes in the mitochondria is just an amazing thing. It's a miracle, really.
It is, yeah.
So a lot of people looked at oxaloacetate early on. There was even a clinical trial that was done with oxaloacetate because they identified oxaloacetate in one of the Japanese medicines from the bush of the anomius plant, and it turns out it has a high amount of oxaloacetate in it. And they've been using that plant for thousands of years for blood disorders. they didn't have the ability back then to see that glucose was high or glucose was low in their blood sugars. They referred to it as other things, but essentially that's what they were using it for. So some very clever people in Japan took out, individual components of this medicine and started testing them against diabetics. And what they found with oxaloacetate is it was very effective in reducing blood glucose levels in type 1 and type 2 diabetics. Reduced fasting glucose levels by about 25% with no side effects. Yeah, and that was in the late 60s. And when I started looking at oxaloacetate, I found this paper and I was like, wow, that's pretty interesting. So I actually flew to Japan to see what was up because I couldn't find any additional studies on it. And Tohoku University is near this small town called Fukushima, which gained a lot of fame later on. And I went in and I found the department and I held up the paper and I said, is this your paper? And fortunately, they spoke English a lot better than I spoke Japanese. Mm-hmm. And they said, yes, that's ours. And I said, was there any follow-on work? And they said, no. And I was like, I didn't know really. And no, don't be ridiculous. I said, why wasn't there any follow-on work? I mean, you had a compound that reduced fasting glucose levels in diabetics in clinical trials. Mm-hmm. Why wasn't there any additional work? And they said, well, it's an older paper. And I said, yeah. And they said, well, it's a natural compound. I said, yeah, it's a natural human compound. And they said, yeah, there's no patent. It was pretty much the end of our discussion. When I was using looking into the research at UCSD, we thought that was pretty interesting that there was already clinical work done, that we know the dosage during that study was from 100 milligrams to 1,000 milligrams a day. And all of that range had effect. We were looking for was things that increase the NAD to NADH ratio, which is nicotinamide adenine dinucleotide and its reduced partner. And the reason we were looking for the NAD to NADH ratio is the work out of MIT and Harvard, Lenny Garante and Dave Sinclair, and they were seeking to increase that NAD to NADH ratio, and they were doing it genetically. These guys are really smart, I'm not that smart. Rather than trying to increase NAD to NADH ratio genetically, I started looking for compounds that could do that, preferably natural compounds, most preferably natural human compounds, because I didn't want to worry about the toxicity. And we did a bunch of toxicity trials anyway. One of the trials is you have to try to see how much of a compound you can give to an animal before half of the animal group dies. It's kind of a sick type thing, but it's important because if you're going to give it to human beings, you need to know how safe it is. And we were giving huge doses to mice and rats, and we couldn't get any of them to die. We couldn't even find negative effects.
How big were your doses?
They were like 5,000 milligrams per kilogram.
Wow.
Yeah, that's huge. That's like, considering like a human weighs about 70 kilograms, that's 70 times 5. That's like 350 grams. The mice and the rats just, yeah.
Were they more synthetic?
No, they, we had to sacrifice them afterwards. I'm say because we had to look at all their organ function and we had to look at all their blood types and everything. Everything was normal, which really surprised us. But I guess it shouldn't, because then again we're dealing with an energy metabolite that is in practically every cell of our body.
Right.
It's giving more of it. So there seems to be no toxic problem with oxaloacetate, but there is a very serious problem in stability. One of the things that we learned when we first started working with it is if you put it in a jar and just put it on the lab bench, in about a week, it's gone. It's just, it spontaneously breaks down into carbon dioxide and pyruvate, neither of which are toxic, but they're not oxaloacetate either.
Mm-hmm.
So we had to look at why they were breaking down.
Mm-hmm.
And here's where my background as a physicist came into play a little bit. There were two different molecules of oxaloacetate, one where the carbon atoms were in a straight line, which was a keto version, and one where the molecules were in the shape of an L, which is the enol version.
Mm-hmm.
And it turns out
E-N-O-L, the enol?
Yeah, E-N-O-L. Yeah, so like an L shape. And so what we were finding is that the keto version was the one that was breaking down spontaneously. And then the enol version, when the keto version dropped down in concentration, the enol version would convert to the keto version and then also break down. So the keto version would go first, and then the enol version would feed into the keto version and then break down also. And so then all of a sudden it was gone. So we found the catalyst that allowed that breakdown to happen. There's two catalysts. One is oxaloacetate. It's enol keto oxaloacetate transaminase. That's quite a mouthful.
Yeah.
And the other one that allows the breakdown is, or from enol to keto, is water.
Mm-hmm.
And of course, in our bodies, we have a lot of water. So that was the problem. So what we did is we figured out how to manufacture this in just the enol state.
Gotcha.
So that now we have like a 2-year plus stability at room temperature.
Mm-hmm.
We've got stability studies for like 3 years now.
Wow.
Yeah, they cost a fortune too. And what we see is less than a 5% breakdown for 3 years, which is really very stable. But we do a lot of tricks. I mean, we keep the water out. The water content is very, very low. We manufacture it in the enol form, and we then isolate it from the any kind of moisture, like even moisture in the air, by having sealed bottles, and we have desiccants in the bottles, and so things like that to get the stability that we need to make it a commercial product. And that's probably one of the reasons why it wasn't a commercial product, is because if something's going to break down in a week, it's difficult to sell.
Right. How do you even get it to your market?
Yeah.
The formulation that you're looking at now in the enol form, it's a lot more stable. Is that right? Yeah.
We've been, like I said, we've been able to get up to a 3-year stability with less than 5% degradation. And we're able to produce it very, very pure. So we thought about extracting it from things like pigeon breast, because it's got a huge amount of oxaloacetate, because it's got a huge amount of mitochondria. But it's better off just synthesizing it chemically and having it like 95% or more purity. And we know all the side, things that aren't oxaloacetate. We had to define all those. And again, that costs a fortune too.
Right. That's how science works.
Yeah.
Okay. Stability has been an issue, but that's been kind of figured out. You did talk about diabetes and oxidative stress as one of the original uses. What do we see research around now for the implementation of oxaloacetate as an intervention?
Well, it for the 50s, 60s, 70s, 80s, 90s, there really wasn't a lot of use for oxaloacetate because, one, it's in such short supply in the body. I mean, it lasts for millionths of a second type thing, constantly being destroyed and then regenerated. But it's always in very, very low amounts. And so it's hard to detect. It's hard to keep stable. And any experiment that you do in the body is in water. So you got to figure, any solution that you put together, you have to make it up every day. And because of all those inconveniences, it really wasn't studied very much. We started studying it back in the early 2000s, mimic the calorie restricted metabolic state. One of the things that was identified in fasting is that your levels of NAD plus increase and your levels of NADH decrease. That is called the redox of the cell. And that change in the redox then turns on other molecules. There's one particular signaling molecule that's pretty neat called AMP, protein activated kinase, or AMPK. And the neat thing about activating AMPK is when we do that, we see an increase in lifespan in animals. And, there's not a lot of things that increase lifespan. I mean, the pyramids didn't work.
Right.
But since then, I think there are only a few compounds that have shown increases in lifespan in healthy animals. Now, in sick animals, that's a different story. And that's, the miracle of modern medicine is that we're able to help cure sick animals. But oxaloacetate was able to increase lifespan by 25 to 50% in short-lived laboratory animals. We thought, this is kind of cool. And, fasting is such a pain in the neck. Because I study it, I did it for a month, and my wife was so happy when I stopped. She just thought I was the most irritable person in the world, and then doubly so.
Right.
But, I hear about people who fast on a regular basis, and my hat's off to them. I think that's just great. I think it's very healthy practice. But I really like ice cream.
Yep.
So I was trying to come up with something that I could take as a pill to mimic the effects of calorie restriction and get some of the benefits, because longer lifespan is pretty cool, and we're not sure if calorie restriction will increase human survival. We do know that it will increase primate survival, the monkey studies, and but it's not just living longer, it's living better. There is less chronic disease, there's less inflammation, there's all sorts of benefits to calorie restriction. And so we thought, if we could come up with a supplement that helps with that, that would be a good thing. And that was the idea behind the product Benagene, which was first introduced in Canada in the mid 2000s and then introduced into the US in 2009.
So let's start talking a little bit more about some of the direct impacts, because we've talked a little bit about longevity and about AMPK activation. We've talked a little bit about inflammation with NF-kappa B reduction. Let's talk about glutamate. What impact does oxaloacetate have? What's the relationship with oxaloacetate and glutamate?
So let's talk about glutamate. In the brain, that's a neurotransmitter. It's essential. But whenever your brain is damaged by, closed head injury, disease, stroke, any kind of insult to the brain, your cells are disrupted and it spits out everything in there. And unfortunately, the amount of glutamate in the cells is about 1,000 times higher than is outside the cells. And so when you flood all that glutamate into the area with neurons or other nerves, it causes them to be excited. So glutamate is an excitatory neurotransmitter. when it excites it so much, these neurons, they just go, oh, wow, this stuff is great. But they get so excited that they die. It's called, it's a real problem. It's called excitotoxicity.
Mm-hmm.
And it's a huge problem in any kind of brain injury.
Mm-hmm.
So they started looking at oxaloacetate because one of the things that it can do is it can bind up glutamate through the enzyme oxaloacetate or glutamate oxaloacetate transaminase, GOT. It's now also called AST.
Mm-hmm.
And that's a liver enzyme that circulates in your blood. And whenever there's excess glutamate and excess oxaloacetate in the presence of this enzyme, it combines the two and makes alpha ketoglutarate and aspartate, which are other metabolites.
Mm-hmm.
And neither of them is neuroexcitatory. So that's a huge deal.
Yeah.
They've shown that if they can give animals oxaloacetate, it can help them with closed head injuries, reducing the damage, the ischemia in the brain by up to 80% if they can get oxaloacetate to the animals within 2 hours after the closed head injury.
Wow. And can you talk a little bit about what dosing has been used in those studies?
They're using huge doses. And I don't recall offhand the actual dose they were using. And again, they were using rats. Maybe they should have used lawyers. I don't know. That's probably been more applicable for what we need to know about dosage. But yeah, they had to use a lot. And we're able to show in the bloodstream about a 60% reduction in glutamate levels.
Wow.
A 40% reduction in glutamate levels in the brain, which is pretty amazing because it means that the oxaloacetate had to cross the blood-brain barrier. Mm-hmm. And, as a very small molecule, it's only 4 carbons big. That's pretty important. So we've been looking at using oxaloacetate, from a research standpoint to reduce glutamate levels in the brain with certain diseases. So we've been looking at Alzheimer's disease and Parkinson's disease and brain cancer, and been doing a lot of animal trials, and we're starting to do some clinical work also. But just a note of caution here, the oxaloacetate levels that we use in those studies is very high, and it's not anything I recommend until we finish the studies. And the nutritional supplements that are available with oxaloacetate have very low levels of acetate, and they're not intended to prevent, treat, cure any disease. Mm-hmm. Just meant to try to keep healthy people healthy.
What kind of impacts do you find at the lower doses? And can you talk a little bit about what a lower dose might be?
A lower dose might be as little as 100 milligrams, which is 1 capsule of the nutritional supplement. Mm-hmm. It was kind of funny. We had the Benagene product on the market for years, and people really love it. Once they start taking it, we have customers for life, really, which is kind of nice. And but we were getting doctors coming in and saying, Alan, this patient came to me and said, my PMS symptoms went away. And I said, you mean premenstrual syndrome? And they said, yeah. And I said, wow, that's weird. And, didn't think much of it until it was said again and again and again. And so we looked at the energy pathways and did some research. And one of the things about PMS is that if they do PET scans, which look at the amount of glucose usage in the brain, one of the things they see in women with severe PMS is that their cerebellum, which is in the very back of their brain, it's kind of a primitive part of the brain, responsible for emotions and other things, movement, is that area of the brain needed a lot of glucose.
Interesting.
It just lit up like a Christmas tree when these women were having emotional issues. And women that don't have that during the same part of their menstrual cycle don't get emotional PMS. And what we theorized is that if you don't get that glucose, if you're not feeding your brain when it needs it, you react just like I do when I don't have enough to eat. I get cranky and irritable. I get hangry.
Right.
And so we thought, it's possible. And we looked at the biochemistry, and what we found is research showing that oxaloacetate is the key molecule that allows the conversion of fatty acids to glucose, especially during fasting. And we thought, oh, okay. So what we think is happening is somebody will swallow some oxaloacetate. It will allow the conversion of fatty acids into glucose so that you can feed your brain. And in clinical trial, we saw a 50% reduction in PMS-related depression and anxiety, and a 48% reduction in suicidal ideation.
Wow. That's way beyond what SSRIs typically get, a 40%.
Well, again, this is for PMS. Now, SSRIs are for clinical depression, and that's a different disease. We're not sure if that's caused by a lack of glucose to the brain. But certainly we've seen huge improvements in women with PMS. And I mean, we had women that were, one woman in particular comes to mind. She said, I had to go home 3 days out of every month and hide, because if I was around anybody, I would lose my friends, I would lose my family, and I would lose my job. She had been doing that since she was 13 years old.
Wow.
Yeah. And so imagine when she was able to go to her doctor and say, I didn't have this anymore. I received these emails from women that, the first month they try this, they send me a 2-page email of how all their symptoms have improved. And then like 2 months later, I'll get another email from them, and, it's still looking good. And they go on, for a half a page. And then in like 4 months, I get this email that just says, send more.
Yep.
That's the way it should be. I mean, PMS shouldn't be the overall concern of their life. I mean, they've got so many other things to deal with as women that, go out and do all those other things,
And that Jubilance, it's the same. Is it regarding dosing between Jubilance and Benagene?
Yeah, it's Jubilance and Benagene are actually the same product. They're just different labels. And we did that to differentiate them in the market, because Jubilance is for emotional PMS and Benagene is more for generalized overall good health. Yeah. We didn't want a bunch of men taking a PMS product.
Right.
Men are disturbing enough as it is without
right.
problems.
And so let's talk a little bit more specifically about chronic fatigue. What do we think is happening in chronic fatigue? You mentioned a little bit earlier with the NF-kappa B level being elevated.
Yeah, there are a bunch of things that go on in chronic fatigue. One is that energy pathways seem to be messed up. This goes back to the cell danger response, where glucose goes into the cell and it's processed in the cytosol instead of in the mitochondria. And that's a quick fix to get you more energy. It can be done very quickly. And that's one of the reasons, for instance, like cancer cells do this. Otto Warburg discovered this back in the 1930s. And Otto felt that once that happened, you can never turn them back. And we also see the same thing in chronic fatigue patients, that this change in energy where not all of the energy is coming from the mitochondria, but where a lot of it is coming from the cytosol through fermentation. And recently, we've did some studies with something called carbon-13, which is an isotope of carbon that we can track very, very finely. And using glucose molecules that are built out of carbon-13, we looked at what happens in a cell that is got this Warburg effect going on. And we were able to reverse the Warburg effect with oxaloacetate.
Interesting.
Yeah, and that was very exciting. We published that in the journal Neuro-Oncology. And then just a couple of months ago, there was a great article in Nature Metabolism showing that really the Warburg effect, which is where the cells start fermenting instead of using the energy in the mitochondria, is dictated by the amount of oxaloacetate in the cytosol.
Wow. So that's a direct potential route.
Very interesting, yeah.
And talk to us, you've kind of a few times touched on glioblastoma as one of the conditions, which is a brain tumor that's been reviewed in the research associated with oxaloacetate. What doses have been used and what outcomes have been seen?
Well, we use very high dosages. Primarily, our work has been preclinical work with animals. And in animals, we're able to show that the tumor grows at half the rate.
Wow.
In a very aggressive tumor like glioblastoma, that can be very important. We've also shown that it increases survival, which you would expect. And that was some of the work done at Boston College with Tom Seyfried. And it was also done at the Weizmann Institute in Israel. And we did it also at Charles River Labs. So based on that, the FDA gave us an orphan drug designation for oxaloacetate for treatment of glioblastoma. And then they looked at our data again and gave us a fast track designation because they want us to try to get this to be a drug faster to help these people. That's in process. And unfortunately, that costs millions and millions of dollars. And it's something we're working through, and hopefully that works out. Right now, I don't recommend oxaloacetate for any disease. I just, the doses that are used are anywhere from 1,000 milligrams a day up to 6,000 milligrams a day. And we primarily just make the nutritional supplement available at 100 milligrams a day. Now, we have been doing some work in chronic fatigue syndrome, ME/CFS. And these are patients that, you and I can get tired and have fatigue.
Sure.
These patients, when they have fatigue, which is pretty much all the time, they are not cured by rest. In a marathon, and I go to bed and sleep for 10 hours, the next day, I feel a lot better. These people, if they walk to the mailbox, it can cause them to be in bed for a week. It's really, unfortunately, something that they haven't been able to find anything that is all that effective for this condition. And it can last for years and years and years. Some of the people that we were studying had ME/CFS for 30 years. And we had heard anecdotally from some of our customers that were taking Benagene, that they were using it to get through their day. They CFS, and we thought, that's really interesting. And then we started looking at ME/CFS and the various issues with fatigue, this increase in the NF-kappa beta pathway, misregulation of energy pathways, through an increased Warburg effect, mitochondrial dysfunction, increase in nitrogen buildup. And all these things, interestingly enough, could be solved by oxaloacetate supplementation. So we put together a little presentation. I talked to some leading people in the field. I said, this really looks interesting. Are you interested in testing this out? And Dr. David Kaufman, who's at the Center for Complex Disease, he's guy's just top notch and clinician, just fantastic. And he said, let's try it. So we decided to do a series of case studies since he already had his patients and they were under his care, and we're allowed to do that. So we started off with 1,000 milligrams of oxaloacetate a day, and then went up to 2,000 milligrams a day. And what we saw in these patients was a drop in the amount of fatigue they had. In some patients, it was almost 100%. Other patients, it was, 5-10%. But the average was about 25 to 30% reduction in fatigue.
Amazing.
In 6 weeks.
Yeah.
Some of these people have had fatigue for 30 years, and all of a sudden they're feeling better.
Yep.
And that was really exciting. So we've just received IRB approval to move forward with a clinical trial. And so we're going to continue the case studies under that guise. And then we're also looking at starting another trial that's going to be placebo controlled, because the other one, since they were case studies, it was all open label. But now we're going to look at doing some placebo controlled, double blinded, randomized, gold standard type trials, and see if we still get the same results.
Right.
Because one of the neat things we've seen in chronic fatigue patients, when they look at their something called metabolomics, how all their metabolites are, we see that oxaloacetate is statistically lower in syndrome patients. And so we thought, if we can just give them enough to get their system running properly again, maybe it will help. And this allows us to qualify this now as a medical food, opposed to a nutritional supplement or a drug. So I have to talk about that for a minute.
Let's hear it.
Nutritional supplements are made to keep healthy people healthy.
Right.
They're not to treat diseases. Drugs are to treat diseases and require FDA approval. And typically you go through a phase, a preclinical phase, looking for toxicity and effect. And then you go to phase 1, which is safety, and then phase 2, which is safety and efficacy, and then phase 3, which is mostly efficacy. And then you apply for a drug license, and then you might do a phase 4 after you have it out there in the public, and just make sure that it continues to be safe. So that's the drug approach. The nutritional supplement approach is, vitamin C and other nutritional supplements that, again, are made to keep healthy people healthy. Now, Congress, in its wisdom, came up with the Orphan Drug Act in the 1980s. And one of the things that it allowed is medical foods. So these would be foods that treat disease. So that's not allowed with nutritional supplements. So vitamin C, for instance, is not allowed to be used to treat cancer, regardless of whether it works or not. It's not allowed. You have to have a drug because cancer is a disease.
Yeah.
So medical foods now are allowed to treat diseases, specifically diseases where there's a shortage of a particular component, like oxaloacetate in the case of ME/CFS patients.
Yeah.
And it has to be overseen by a physician. There's no prescription necessary for medical foods, but the physician has to advise the patient on the dosage and how to use the product. We developed a medical food for chronic fatigue syndrome patients called oxaloacetate CFS. Those are much higher dosage. They're 500 milligram capsules of oxaloacetate instead of 100 milligram. And instead of 30 capsules per bottle, which is, 1 capsule per day for a month, we have 90 capsules in there. So you're taking, 1 capsule with each meal. So 3 times a day. So you're taking a lot more oxaloacetate, 15 times more oxaloacetate for chronic fatigue syndrome in order to kind of jumpstart your body back into normal function again. We're trying to push your metabolism into something different, but into something that it used to be, functioning.
Pretty interesting stuff.
Yeah, I've had a lot of fun, looking at all these different things that oxaloacetate does. One little metabolite that we've known about since, the early 1900s.
How young an age can kids tolerate or take oxaloacetate? Is there a too young age?
Well, we did all our clinical trial work on adults. 18 and above is where we have all our data. It has been used on a case-by-case basis by physicians on certain mitochondrial diseases in children as young as less than 1 year old.
Oh, wow.
Yeah, and they use a lot of it, as far as the amounts, 2 to 3 grams a day in infants. And, there haven't been mitochondrial diseases in children are fairly rare. So thankfully it hasn't been used a lot. But where it has been used, they did see some benefit. Interesting.
We've really run the gamut all about oxaloacetate and what else?
I just have to reiterate some things to not mislead your public. I am not a physician. Take nothing I say as medical advice. Take it as the guy next door who changes tires. And hopefully you won't be tired if you take oxaloacetate.
Yep.
It's not a drug, so don't use it to treat diseases. But you can use a medical food to treat ME/CFS, chronic fatigue syndrome.
And it's available through your company, Terra Biologic.
Yes, we manufacture it and distribute it. We have a couple of websites online. One is benagene.com, benagene.com. And then we also have for the PMS product, jubilance.com. And then for the higher dose medical food, you'll have to go to oxaloacetatecfs.com, which is helpful. And because of that mouthful, we also have a redirecting website that is me-cfs.info. So that might be easier to remember than oxaloacetate, which...
Amazing. Thank you for sharing all of that with us. It's a supplement that I've used quite a bit in practice, especially with long COVID, post-viral fatigue syndromes, lots and lots of different kinds of things. And I'm really grateful for you talking to us about all the different aspects of oxaloacetate today.
Well, let me ask you, how are your patients doing on it?
So, well, it's interesting because I've got some patients on the 100 milligrams. So I saw a patient today who's got hot flashes, who's just she's, I think, a little bit of time postmenopausal. And she has been having fatigue for a long time, and she's a patient with biotoxin illness. And so she's been taking just 1 capsule a day and hasn't felt very much. I've had other patients who have been taking higher doses. And what I typically recommend is up to 2 caps twice a day. But I sometimes will talk to patients about how in the research, way higher amount has been used. And then those patients who do the higher dosing typically do better.
Interesting.
Yeah. But I've had comments ranging from more energy to more mental clarity to more stamina. Not everybody loves it or feels 100% from it, which I don't actually expect. But for the most part, patients do seem to tolerate it very well. And so it's a fairly benign intervention. It doesn't seem to have a lot of side effects or impact other than kind of what we're trying for. So that's also kind of nice. Every once in a while I get a headache or a stomach ache or some nausea.
Yeah, we keep track of the adverse effects. And in our Benagene product, for instance, which is 100 milligrams of oxaloacetate, over the last 14 years, we've had 4 reported adverse effects.
Wow, that's pretty low.
2 headaches, 1 rash, and 1 acid reflux is a pretty safe profile for anything. And it kind of goes back to, those tests that we did in the mice where we force fed them huge amounts and saw what happened.
Yes.
And, they were just happy little mice.
Yep. Great. All right, my friend. Well, we've got a lot to think about with oxaloacetate. Patients can find you at your website, which is what again?
They can go to benagene.com, benagene.com, or jubilance.com, or oxaloacetatecfs.com.
Okay.
Thanks so much.
So thank you so much for being here with us today. And thank you all for listening at home. We've got lots of ways to continue this conversation through Facebook, Instagram, and Twitter. You can get more information about Mr. Cash at the websites he just mentioned, or about and from us at our website, centerforhealingneurology.com. Please be sure to share the show with your friends, especially all those tired friends who have PMS. We welcome your rating and review wherever you get your podcasts, and feel free to send topic requests to podcast@centerforhealingneurology.com. We love that you've joined us today to discuss how to make our whole world medicine. We rise or fall together, and we're committed to doing what we can to make as many of us as healthy as possible. And this takes all of us, including you. Thank you for listening, and see you next time.
Partyfish Media. Partyfish Media acknowledges that it operates and records on indigenous Duwamish and Puget Sound Coast Salish land that is still home to the Duwamish tribe. This land is stolen in violation of the Point Elliott Treaty of 1855. We are committed to uplifting the name of these lands and community members from these nations who reside alongside us. For more information on this land, its people, or ways you can help, visit duwamishtribe.org.